You are given a solution to linear unforced differential equation. So this form. So this is the general solution. But how can we determine A, the unknown A and unknown B? How? Hi, Assalamualaikum. Okay, so in this lesson, you are going to have a solution to second order linear differential equation with initial conditions. In the previous lesson, you have learned about to finding out the general solution. But in this lesson, you will find out the specific solution with given of the initial conditions. So at the end of this lesson, you will be able to solve second order linear unforced differential equations with initial conditions. Okay, let's move. Alright, so let's take back the example from the previous lesson. You are given these equations, and then but now with the additional information, what we call as an initial condition. Okay, you are given this initial condition. Okay, so from the previous lesson, you have known that the general solution for this type of differential equation is this one. Okay, this is general equations, general solution with where we do not know what is A and what is B. Okay, so next what you should do is that you have to make a first derivative because you are given this condition. Okay, so you make a first derivative of the general solution. Okay, and then you rearrange back in the simplest form. Okay, what you have to do is that you use this information, we put into this and substitute t equal to 0. So that means you substitute t equal to 0, t equal to 0, okay, and equal to 1. Why? Because why is 1? Because here, okay, x t equal to 0 is 1. So because b times 0 is 0, so this becomes 0. Okay, 0. And then this is equal to 1. Right? Exponential power by 0 is 1. So that's why we get a equal to 1. Okay, now we know a. Next, we want to get b. What we have to do is that we sorry, this is wrong. This is t, the large t. Okay. Okay, then substitute all t equal to 0. So sorry, this is okay, so this is 1 because a equal to 1, right? Because we know that a equal to 1, so that's why we substitute a equal to 1 inside. So alright, so we have all of this. This is equal to 0, we can cut it out. So this is equal to 1, right? This is equal to 1 because exponential power by 0. Then what we will get, this is equal to 2 because from here the second derivative is equal to 2 at t equal to 0. Then we get finally b equal to 4. So since we know both of them, then we have a specific solution given initial condition for this linear second order linear unforced differential equation is given as d. So this is only particular to this condition. If we change the conditions, we will get different solution. Okay, so make sure that you understand that this differential equation will have different solution when you are given different initial conditions. Okay, let's move to the next example. In this example, also you can refer back to the previous lesson where we get complex M solution. Okay, so what we have to do is that in this example, it is given initial conditions. Okay, x at t equal to 0 equal to 1. The first derivative at t equal to 0 is equal to 2. So the same way what we did before, that okay, so let us write down again the general solution. This is done in the previous lesson. Then we make a first derivative of it. So if you find something wrong about this derivative, so please tell me. Something hidden behind my camera. Okay, so finally we have the simplest form, we can say. The first derivative can be represented as this expression. Then we substitute this initial condition into here, 0 0 0 0 0. Okay, so fine, so this is equal to 1. Okay, this is equal to 1, this is equal to 0. Okay, so that means we don't have this term. Finally, we have a equal to 1. So we get a equal to 1. Then we put the second initial condition into the first derivative. Okay, so include 0. So 0, what else? 0. So actually this sign 0, we can just cut it out correctly, correct? If I'm not wrong. So this is equal to 1 because exponential power by 0, anything power by 0 is equal to 1. Okay, finally this is equal to 1. Then finally we get b equal to 3. Then we can substitute into our general solution. Okay, so for this particular second order differential linear unforced differential equation with this condition is given by this solution. Okay, so we return to the teaser. So you are given this one. Okay, how can we determine value of a and b? We cannot determine a and b without having initial condition. Only when we can have this information, we can solve this second order linear unforced differential equation. Okay, so because we can because we need two information at least. Okay, to determine the solution for the specific solution for this, for actually for any second order differential equation, we need two information so to help us to determine the unknown constant. Okay, so in the next lesson, what's that? In the next lesson, we will look into the special case of the second order differential equation. Alright, see you then.